Hello everyone, myself Manish Ram and my register number is URK23AI1108. Today I will be explaining the experiment based on sequence to sequence LSTM model using Keras and TensorFlow. First, I import the necessary libraries TensorFlow, NumPy, and modules from Keras such as input, LSTM, dense, and model. Next, I define a key model parameter called latent dimension, which I have to set to 256. This value represents the number of memory units in the LSTM layer, determining how much information in the network can be remembered while processing sequences. Then comes the encoder part. The encoder takes an input sequence with 100 features per time step. It processes this sequence through an LSTM layer that process it and compress the information into two internal states, a hidden state and a cell state. These states carry learned context from the input sequence, which will later help the decoder generate the output. After that, we move to the decoder part. The decoder is another LSTM layer that takes the encoder's output state as its initial state. This means the decoder starts with the context learned from the input sequence. It generates the output sequence step by step. A dense layer with a softmax activation function is used to produce the final output probabilities for each possible token or value at every step. Once both the encoder and decoder are defined, I combine them into a single model specifying both the encoder and decoder outputs and compile it using the Adam optimizer with a categorical cross-entropy loss function. This setup helps the model optimize its prediction for sequential data tasks. After compiling, the model summary is printed, showing all layers and the total number of trainable parameters. Finally, the model successfully completes training, showing that the architecture is properly built and ready for sequence-based learning tasks. In summary, this sequence-to-sequence LSTM model demonstrates the core concept of how deep learning models can convert sequence into another, forming the basis for advanced natural language processing systems like Google Translate and chatbots. Thank you.